In this lesson, we're going to talk about triangles. A triangle is a polygon with 3 sides and 3 angles. On the triangle on the left, the sides AB and BC and AC. The angles are angle A, angle B, and angle C. The Angle Sum Theorem states that if the sum of the measures of the 3 angles is always 180 degrees. So no matter what type of triangle you have, if you add together all of their angles, it adds up to 180 degrees. So we can say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. And we can say this is true for all types of triangles. And we can use this to help us find missing angle measures. Let's take a look at a couple of basic examples. Number 1, I know that one angle is 64 and I know one angle is 35, but I can use the Angle Sum Theorem to figure out my third angle because I know all 3 added together have to equal 180. I can write the equation x plus 64 plus 35 equals 180. All 3 of my angles added together. I can use my knowledge of solving equations to find out what x equals. I can start by combining like terms, 64 plus 35. That would give me x plus 99 equals 180. I can then subtract 99 from both sides, and I find that x equals 81 degrees. And I can always check it by substituting it into my triangle and then adding all 3 of them up. 64 plus 35 plus 81 equals 180. Number 2, again, I have another triangle and I'm given 2 of the angles, 34 and 122. I can write a similar equation, x plus 34 plus 122 equals 180. My 3 angles added together equals 180. Then I can use my knowledge of solving equations to combine like terms, 34 plus 122. That would give me x plus 156 equals 180. I can then subtract 156 from both sides, which gives me x equals 24 degrees. Go ahead and highlight numbers 3 through 6. And let's take a look at number 7. So number 7, we have 2 triangles. So when I look at these 2 triangles, if I look at the bigger triangle, I can see that I'm given one angle is 68 and another angle is 33. Looking at just this triangle, I can write an equation to find the measure of angle 3. That equation would be x plus 33 plus 68 equals 180. I can then solve it by combining my like terms, 33 plus 68. That would give me x plus 101 equals 180. Subtract 101 from both sides, and I find that x equals 79 degrees. And remember, 79 degrees was for angle 3. So the measure of angle 3 equals 79 degrees. My smaller angle, or my smaller triangle, if you notice, I only have 1 degree measure. But I can use what I've learned about angle relationships, and I know what the measure of angle 2 is. So the measure of angle 2 and the angle that measures 68 degrees are vertical angles. We know that vertical angles are congruent. So I know that the measure of angle 2 is 68 degrees. So on the right, the measure of angle 2 is 68 degrees. Now that I know that, I can set up another equation to find the measure of angle 1. Angle 1 plus 68 plus 93 equals 180. Because all three of these add up to make another triangle. Combine your like terms. 68 plus 93 tells me that x plus 161 equals 180. You can subtract 161 from both sides, so that x equals 19 degrees. So the measure of angle 1 is 19 degrees. Go ahead and highlight number 8. Number 8, you have a different shape, but using that same knowledge, finding those 4 angle measures. So using what you know about supplementary, complementary, vertical, and adjacent angles. Now, these triangle problems of finding angle measures can get just a little bit more complex, where your equation you write is a little bit more complex to solve. So number 9, I still have a triangle. And number 9, I know all 3 angle measures, sort of. I know that this angle is 121. I know that this angle can be represented by 5x minus 11. So I don't know the exact degree measure, but I have an expression that represents it. And the same thing for my third angle. But just like every other triangle, all 3 of those added together equal 180. So when I write my equation, one angle, 5x minus 11, plus another angle, 3x minus 2, plus my third angle of 121 equals 180. Then I can combine like terms. So I can combine 5x plus 3x. That gives me 8x. I can also combine negative 11 minus 2. That's negative 13 plus 121. Negative 11 minus 2 plus 121 is a positive 108 equals 180. I can then subtract 108 from both sides. That would give me 8x equals 72. Divide both sides by 8, and I find that x equals 9. So I didn't find those 2 degree measures, but I did find out what x equals. If you needed to, you could take x, what you found was 9, and substitute it in and say 5 times 9 minus 11 and 3 times 9 minus 2 and actually find those angle measures. But for this problem, we just needed to find out what x was. Go ahead and highlight number 10. Now let's talk about some of the types of triangles. The first type you have is an acute triangle. So when you have an acute triangle, all your angles are acute. So for example, it would look like one of these triangles. all of your angle measures measure less than 90 degrees. If you have one angle that is obtuse, it's called an obtuse triangle. So that might look like, here's an obtuse angle, and then you close it to make a triangle. And then the ever popular, a right triangle. Remember, with a right triangle, you have to have the box in the corner to show that it is a right angle. We cannot assume that it is a right angle. So those are the types of triangles based off of their angles. We can also look at triangles based on their sides. For example, if I have a triangle where none of my sides are equal, so none of them are congruent, that means this side is different than this one, but then they're both different than that third side. We call that a scalene triangle. Another type of triangle is when two of your sides are congruent. So this side might be the same as that side. We call this type of triangle an isosceles triangle. And lastly, if you have a triangle where all three of your sides are congruent, they're all three the same, that's an equilateral triangle. So let's practice classifying some triangles based on the angles and based on their sides. Number 11, I only know two angle measures. Well, in order to classify it, I'm going to need to find out that third angle measure. To find out that third angle measure, I'm going to subtract 180 minus 40 minus 24. And I find out that third angle is 116 degrees. So then to classify it based on its angles, I can say that it is an obtuse triangle because I have one angle that measures obtusely. To classify it based on its sides, since all of my angles have different angle measures, that means all of my sides are going to have different angle measures, which would make it a scalene triangle. Looking at number 12, we can tell off the bat because of the square in the corner that this is a right triangle. Then, based off of the sides, I have two sides that are the same and one side that is different. So that would make it an isosceles triangle. Go ahead and highlight 13 through 16. And remember, these tick marks tell you that all three of those sides of number 14 are equal because they're all the same number of tick marks. In number 15, it's telling you that these two sides are the same because you're using the same number of tick marks.